Hi everyone, I'm Amoroso from Tag Cyber, and I'm here with my friend Moolchandani, who is the CISO and CTO of a company called Accurics, and it's a very cool company that does infrastructure as code. And we're going to learn a lot about DevOps and DevOps security from who's an expert, both as a practitioner and also now providing technology solutions. Well, welcome. Nice to see you.
Thank you, Edward. Great to meet you, and thanks for having me.
It's nice to see you. So why don't we start real briefly? Accurics is a company that serves the DevOps community. Tell
Mhm.
us a little bit about what you guys do. And then I want to go back, and there's a lot of different topics that I don't understand well that hopefully you can explain to me and others can learn as well. But what do you guys do for a living?
Well, the the name Accurics has a lot of answers hidden in it for your questions. So, Accurics for us means accurate infrastructure as code security. That's why the last ICS stands for that. We offer technologies and products that self-heal the cloud native infrastructures. At the moment, we provide solutions for securing cloud infrastructures, especially which are built using cloud native technologies. And we enable the developers to do security in a right manner for the cloud infrastructures using methodologies which are going to reduce the cost of remediations for developers dramatically. So, in short, a lot of the technologies today in security world provide their value by being on the right side or being on the runtime. We provide similar value what runtime tools can provide by being on the left. That means at the design time or at the pre-deployment time. This movement is also called as shift left movement. But from the offering point of view, our primary value proposition is to reduce the cost of remediations for the security problems that would have later emerged in the runtime. And predominantly, that's because fixing problems when you detect them in runtime is expensive, both in terms of time as well as in terms of dollar value. That is what we reduce dramatically by detecting your future security problems that could have occurred in your runtime by analyzing your code that the developers write for deploying the cloud environments.
It's very exciting. I mean, you could argue you've shifted as left as you can go. I mean, if I'm doing automated self-healing during, the early stages of DevOps, that's about as far from, this detection and response. That's these themes you see where everybody's shifted right and are building responses to problems. You guys are literally at the other end of the spectrum. That's very exciting to see.
Correct.
So, congratulate you guys on that.
Yeah, and our intention is not to claim that you do not need runtime security tools.
Yeah, sure.
Um, that's not what our claim is. You still need your runtime security tools, but runtime security tools should not be focused on detecting trivial problems that can easily be detected by being in the design time. And then, we also provide enough context to the runtime to tell them what they should be focused upon in terms of protecting. We help runtime tools also fine tune their detection signatures and detection algorithms. So because we have the context how a cloud environment was built, and in this entire new world of DevOps, the core foundation that is coming in from infrastructure as code technologies. That is what has enabled players like us to do security from the left. In the previous world, it was impossible to kind of know that the application that you are about to deploy on your runtime is going to be exposed in which fashion and will allow what kind of weaknesses for the attackers if the application is hacked. Today, it is possible for us to detect these post exploitation scenarios. We are not into detecting application level vulnerabilities.
Right.
So, a little bit more technical answer is that we do not detect CWEs,
Yeah.
right? So we don't detect your OS top 10 vulnerabilities in your application code. But what we detect is that if your application gets exploited and the attacker takes over your compute environment, then what all lateral movements are possible for the attacker to do because of the insecurities that are available in your infrastructure, right? That is where we focus upon, and we report that, even before your application is deployed. So we tell you that you were about to deploy an application, which if gets exploited, would have directly allowed the attacker to take over the database because of the over permissions that are available and many other misconfigurations. That way, we help our developers as well as our security folks to focus on hardening those pieces in your architecture which are crown jewels for you, right? That's the value that we provide.
Let's take a scenario. Tell me if I've got this right. I'll tell you what I'm sort of thinking, and I hope this is right. So if there was some big breach and I go work backwards and realize that it was say an Amazon breach, and then I work back further and I see that something wrong in an S3, and I work back even further and realize that during DevOps, somebody just didn't have the right policy, didn't click on check on something simple like versioning or whatever. You guys would have stopped that during DevOps. Do I have that right? Like the policy checking would have stopped it, and all the things that happened subsequently just would not have happened. Is that the right way for like a CISO? Because CISOs don't do development, but
Yeah.
they might be interested in understanding how this cascades out. Am I saying that right?
No, you got it absolutely correctly. So that's the one whole pillar of doing security on the left, which is driven by a strategy called as policy as code. So
Yeah.
this entire enforcement process that you spoke about, 80% of the security hygiene issues and hardening problems can be resolved by adopting policy as code and enforcing those policy at the development and design time. So the S3 bucket issue that you raised, that is 100% possible to not only detect if you were about to spin a S3 bucket with these permissions enabled or certain misconfigurations being enabled on it, but you can fix them as well. But that's the foundation of achieving a larger goal, which is you just don't want to now harden your environment. You also want to identify what are those critical paths that are being created, which can enable an attacker to conduct a full breach, right? So yes, as a first adoption milestone, our customers, adopt us for policy as code and they identify their policies. We provide like 2,000 plus policies out of the box in the product, and we use 100% cloud native technologies to deliver it. We use a framework called as OPA, Open Policy Agent, which allows us to solve the problem of polyglot IAC. Infrastructure as code also is written in many different languages. We bring all those infrastructure as code technologies under one platform, and then we apply OP on it. So that way the customers don't have to write multiple policies to achieve the same outcome. So if you want to write a policy for S3 bucket, you just write it once on our platform. That policy will be applied onto your runtime as well as onto, say, Terraform, as well as any other infrastructure as code that you may be deciding to kind of, write your code for in the language. So that's the one maturity milestone. The next maturity milestone then is then we need to be able to also cover up scenarios such as this. So yes, you have a S3 bucket and you've hardened it. Great, right? But do you know how many EC2 instances you have in your environment who have got an IAM role assigned to them with S3 star as the permission, right? You need to then know those things as well. So this is where what we do is we build full relationship matrix between all the different assets that you have in your cloud environment. That has become possible again because of the codified nature of cloud. You not only codify, you write a piece of code to spin S3 bucket, you write a piece of code to spin your RDS instances, you write a piece of code to spin your EC2 instances, but you also write piece of code now which defines the relationship between them. That code also goes into your normal infrastructure as code, which the DevOps teams are writing day in and day out without realizing that there is so much of rich data available now for somebody to analyze. We analyze it and we create the full relationship matrix and we understand that on the scale of 5 different relationships: network, identity, access, privilege, and native. We create relationship matrix between all the assets. So now what we are able to detect is that if you are using Terraform to spin few EC2 instances, we can tell you that you were about to create an EC2 instance which had a permission as S3 star. Now, out of the 50 S3 buckets, you have these 4 S3 buckets, which are your crown jewels because you are hosting some critical data there. Other ones, which are 46, even if you're not encrypting them, it's okay. These 4 you must, or we can offer a self-healing process where we can create a policy which can automatically be applied onto your EC2 instances to take away the permissions from those 4 S3 buckets, which are your crown jewel, because you do not want everybody to have access to that S3 bucket. This way, what we are doing is tomorrow, if your EC2 instances are hosting any application, right, and that application allows the attacker to penetrate into your compute. That is what happened in Capital One breach, right? One application vulnerability allowed the attacker to get inside. So attacker won't be able to do the lateral movement so easily. The attackers will have to think through now and will have to discover more relationships. That's where we excel. So, but that's a second level of maturity for our customers. You still have to adopt policy as code first to be able to do then the next level, which is called as security as code.
I wanted to ask you, my experience with development is that so many of these policies are just seem so obvious, like enabling encryption, things that it makes me wonder if there's not some determinism here. Like, is it a matter of there's a best practice and you guys will always find the optimal state, or do developers have decisions? Like, there's just so many these policies, you look at it and it's hard to find scenarios where you shouldn't be doing that. Like, do developers have some, is it possible for them to make bad decisions, or does your tool essentially say, look, these are no-brainers, just do them. Make sure you map it to your architecture. But I've always wondered why I can never think of examples where there'd be an easily debatable policy to go left or right.
Right. And before I answer you that, just a little bit of background on this problem. You
Yeah,
know, all the cloud providers, all CSPs, cloud service providers, have got pretty good security layer available for all
hmm,
the services that they offer. They offer quite a few security settings which you can use to kind of
yeah,
create your defense in depth, layers. And almost all cloud service providers have got these controls available, which can be enabled using settings, which are configuration, right? The one thing that is missing is that by default, they don't come
yeah.
enabled.
The default is off, right?
Right.
Yeah,
Default is off.
right.
And one of the big reasons why default is off is one is the performance.
Yeah,
The second reason is missing documentation about what is going to happen if you enable it.
yeah,
So for developers, when you don't give them documentation that if you enable this, what is going to happen, they take the doomsday scenario automatically. That, if I enable this, this is going to cause problems for me.
right.
Let me just enable things which are not going to break my application. Because see, the developers and the DevOps teams, the SRE teams, their primary job is to keep the show running, which is keep the applications running.
Yeah.
If anything can come in between that objective, they're going to reject it. So
Microsoft invented this whole concept, right? In the 90s, ship everything wide open and hope that nobody calls their help desk is
right,
terrible. I think they
yeah.
still,
So that's why now where we are moving is that we have ton of these security settings available, which are basically which get translated into your policies, right? But what is missing today for the developers is to understand the risk context. Unfortunately, one thing is also true that if you have hundreds of policies available, at a certain layer in your architectures have got multiple layers, just
yeah,
like how we have the multiple layers in our atmosphere, right? Each layer provides a different kind of protection. Your layer where you have most amount of exposure, your microservices or your endpoints, your service endpoints or your REST endpoints, for that matter, applications which are directly exposed through Internet Gateway or Elastic Load Balancer, that layer requires different kind of treatment when it comes to enabling the policies versus the layer which is deeply buried in your core. You don't need to enable all the policies there. Sometimes it's going to otherwise cause a huge performance penalty, right? But that is where one needs to have full visibility into their architecture, that what are those core hidden crown jewels which live at the belly of my architecture, which are still exposed to, say, internet through direct or indirect relationships. And those assets have to be identified. And then you can educate developers through the products, through the tools, that listen, you need to go ahead and enable policies for these elements, right? But for a certain layer, you should enable all these policies. Because eventually, as I said, for development teams, right, yes, security is not their first, priority, but they know the security is no more the second class citizen anymore, right? So what we are therefore doing, and where we are going with this, we are doing policy as code, but we are also contextualizing the risk to demonstrate that, well, if there are CIS benchmarks, 120 benchmarks for AWS, right? Which ones you should enable at what risk layer? That is very important for us to provide as an outcome. That's where the value is, and risk-based approach still works. So both security teams and development teams are able to communicate to each other if there is enough context and rationale available. So what we do is, in our product, we help security team understand that what is the risk context, say, of a RDS instance, which is deeply buried in your network. It's not directly exposed to internet, right? But if there is an RDS instance which has got a IAM role shared with another EC2 instance, and that EC2 instance is hosting an application which is exposed to internet. So we showcase these relationships, and then we tell them that now on this RDS, you should enable the encryption, right? Although it was only going to prevent you against the last mile of the attack, which is data dump. Before that, the attacker has to do many other things. But you should do that for this database, as
Right.
compared to maybe some other AWS service or Azure service, which doesn't have that kind of risk context. So you don't have to enable there, right?
Mhm.
That's a difference, and that is what is something which allows developers to adopt policy as code. Otherwise, nobody's going to adopt policy as code. If you tell them you need to enable all of these 200 policies in one go, that's not going to happen.
Interesting. Are you seeing, as we do, just about every developer shifting to a Kubernetes model? Is that essentially? It seems like it's taking over DevOps architecture at this point. Is that something that in the product
Mhm.
that you guys are designing toward? Seems like a big wave. I don't know if you seems like you're seeing the same thing.
Well, one thing is what we believe, the other thing is the empirical evidence, right? So the fact that we have companies like D2IQ, we have players like VMware coming out with Tanzu, and
Right,
then have Cisco coming out with their AIS or ACI, something like that, their multi-cloud control plane, right?
right,
And then you have players like OpenShift, going towards cluster management. I mean, the fact that now in industry we see large players who are, and of course you have EKS and AKS and GKEs of the world, right, which are managed Kubernetes services. The adoption is on rise. This is a clear indication that industry has gone beyond containers now. I mean, so container orchestration wars they were happening in 2015 and 16, and now you have cluster management wars
right.
going on. That means the large enterprises are adopting Kubernetes clusters to a large scale. That's why you need cluster management.
Mhm.
So this is one empirical evidence which says that there's a lot of adoption going on for Kubernetes, and I think maybe a few years from now we will see technology companies which will purely run on 100% Kubernetes, right? And that day is not that far. So in that case, of course, one you know one big problem gets solved, which is of DevOps, right? Industry is going to move towards GitOps in that case. GitOps is a strategy which is specifically designed for Kubernetes. In fact, the official definition of GitOps is that it is a code-based infrastructure and operational deployment practice that rely on Git, and it uses infrastructure as code and DevOps practices for high velocity CI/CD for Kubernetes. So in the official definition itself, you have Kubernetes
Right.
involved.
Yeah.
Uh, so GitOps adoption is something which is going to be natural for Kubernetes-based environments, but there is one problem as well. GitOps is a methodology where you sync the state of your Kubernetes cluster with the code. Technically, there is no separate, pipeline installed somewhere else, which is going to continuously pull the code and provision your environment. Your environment is already pre-created. You put a GitOps tool inside it, like a Flux or a Argo CD, and that tool is constantly looking to your Git repositories, which are holding infrastructure as code, such as Hemchart or customized template.
Yeah.
So the developers now, all what they have to do is they don't even have to worry about this pipeline. They don't even know it's transparent to them. All what they do is they continuously modify and update hem charts and customized templates and check in into the Git repository. From there on, these tools automatically pull the code up and sync the state of the cluster, right? That means this is kind of a no ops situation, right? So GitOps actually is a foundation for building no ops to a large extent. I mean, there's nothing called as no ops for that matter. It's the speed at which things move, which gives us the illusion of no ops. But then the security has to catch up with that. So what that means now is that there is more and more value in doing security using infrastructure as code and catching all the basic security issues right before those issues hit the cluster. Because once a security vulnerability or a security problem reaches to a live cluster, it is going to be that much more expensive to run the whole cycle of fixing the ISC, then rerunning the pipeline, and then rebuilding your.
Right. Yeah. The self-healing nature of your platform fits in nicely with that concept.
Yeah.
That's really good. Oh, and for people who have some interest in Accurics, what's the best way for them to learn a little more? Is the website the right place to get in touch with someone for a demo?
Yeah, and we do offer a freemium solution at
Oh,
app.accurics.com. One can go and register there and then play around. There's a playground available. We offer connecting to any kind of cloud environment or a Kubernetes cluster, and one can just go ahead and connect their runtime clusters as well as their pipelines to play with the code and perform infrastructure as code analysis. And we also have an open source project called
mhm.
Terrascan, which is a very, very good starting point for anyone who wants to learn this subject of policy as code and shifting infrastructure security to left. Terrascan comes with a lot of different features. It handles polyglot IAC, it handles different forms of infrastructure as code, including Kubernetes. And very soon we are releasing our Kubernetes admission controller as well for Terrascan, which is going to allow the end users to enforce policies not only in pipeline, but also as a last mile protection within the admission controller also for a Kubernetes cluster.
That's an excellent story. I certainly learned a lot in the last half hour. I want to thank you on behalf of our team at Tag Cyber and for everyone listening. Thanks for taking some time to educate us. This is an exciting area. You don't hear too much, too many cases where self-healing really works. This is one of them. And congratulations on great stuff.
Thanks, Ed, for having me. Appreciate it.
Wonderful to see you. And for the rest of you, we'll see you all next time.